Hi everyone, this is John Wen. Today is June 10th, 2020. In today's video, I'm gonna briefly go through what have been done in past week for the research items. So you can see from this Gantt progress diagram, there are two items highlighted in this progress bar. The first item is a extended survey to journal version. I estimated the progress since that last week, I think, is about 5%. And the second item is about the deep learning workflow. I estimated the progress is about 3% since the past week. So you can see from the detail, for the first item, I added the algorithm WRPS to the paper with its description, pseudocode. They are ready as the initial version. Of course, they can be improved as time goes by. Maybe I will come back to it sometime after today's meeting and make it better version for review. So this is the first one. And second one is I received many suggestions from last week's group meeting, and I think those are very helpful, and I listed out some of them, most of them here. So I marked already been finished items as green background, and I leave two here, so maybe I can brought it up in today's meeting and discuss how we can move forward. For example, for the introducing the Heft algorithm somewhere in the paper. So I'm wondering whether the Hefter can be added as a section or a independent algorithm in the section we introduce the algorithm. So that's something we can discuss, or shall we introduce this in one of the algorithm, for example, like the shift. I think the shift is the first one to touch with this Heft algorithm. So this is the first one, and second one is by suggesting me to change the complexity of the output to the new version. So I'm thinking about this one because we're still referring to the old paper. I'm wondering it is proper to change to the new version of the complexity, since there's no where people can find this new complexity or this new algorithm based off a reference. So this is something we can discuss in the meeting today. But other items, like we use the same annotation for all the algorithm. For example, we change a capital W to the WS, which stands for the workflow string. And we also change the DBDS algorithm 1 or 2 to DBDS A or DBDS B. This change has been done in the description or in the explanation as well. And also I fixed other small items. And thanks to Dr. Liu, we are introducing some special symbol, as well as some notations or some comments to improve the readability for pseudocode. And I think this is in progress, and some of them have already been done. And the second item, to work on the deep learning workflow, I keep working on the high level design of the workflow, how it looks like in the data view. Many thanks to Dr. Liu, he forwarded me some slides as well as the videos, tutorials on how to construct a neural network in Java. So I think this is one of the screenshots on YouTube video, and this is a very good video to introduce how to construct the new neural network, including the backpropagation. And also there are other videos to introduce what kind of neural network should be like when we write them in objective-oriented language. So here is some questions we discussed last time. So basically, we can start from this kind of simple neural network. Basically, it's a multi-layer perceptron. So we can start from those kind of small network, and there's some other screenshot of the YouTube tutorial. So I think this will be very helpful, and I will go through them maybe afterwards. And I think this is helpful to design or to write the CPU version of the workflow and make it work in maybe local executor, local workflow executor. So you can see from here the first designs corresponding to what we've been talking about. Firstly, we have a neural network workflow that can be constructed by assemble or connected by different tasks, and then we throw this workflow into the executor. Depends on which kind of executor we're choosing. Maybe we can choose the CPU, or we can choose a GPU version, and then we can get corresponding output. So this is a very ideal design. I think if we can do like this, that will be very good, because we can always use unified workflow. So here I summarize a goal. The firstly, we have the unified tasks or workflow that can be executed on CPU or GPU, like TensorFlow, because TensorFlow, if you write the code once, you can either execute on the CPU or the GPU. So where to execute this code is totally depends on which workflow executor we are choosing. If we choose a CPU version, and it will run on the CPU. If we choose a GPU version, we will run the GPU. So that's the idea. So the workflow executor is responsible to take care of how and where the tasks will be executed. For example, whether it's on a VM, it's on a thread, or it's on the GPU or CPU. But there are some challenges we need to take into consideration. So firstly is Java is not that well supported in the GPU programming and Python. So the Python is one of very good language that can directly interact with the GPU, and also it's very good at manipulating the matrix, manipulating the data in the GPU. And the second challenge is that the CPU programming and GPU programming can be quite different in Java program. So such that if we write a task underscore GPU.java, it may contains a lot of non-Java code. So maybe it will be very hard for us to unify a task or unified GPU and CPU task in one file or in one Java code. So that will be a little bit hard. And I also tried on the Apache Pi in the Eclipse. I believe it's not here. It's in another workspace. Maybe I will not show it today. But I tried to wrap a whole task in the kernel. But I play around with it. So far, there's no fortune to get any data back or get it to work. So what I assume is that the GPU is working on some specific tasks, specific code, like the matrix computation. But most of work, if we want to interact with the GPU, that will cause trouble, cause problems if we do if else or if we do while. So those things may not be able to handle by the GPU itself. So we have to coordinate between the CPU and GPU. So that comes to another type of design. So firstly, we have two different versions of the workflow for the neural network. The first one is a CPU version, and second one is GPU version, because we have different code in the task. Maybe the task from the CPU cannot be reused in the GPU version. And then we throw them into different workflow executor. For example, like the GPU version or CPU version, we get the output. So what I'm currently focused on is I think I'm more interested in to set up one GPU version first, because I think if we make a CPU version in DataView, it's very good, but it will be not that kind of transferable, or the code cannot be borrowed to make up a GPU version. But but as I said, maybe I will go through the video, the tutorials video that Dr. Lu forwarded to me, how to construct a CPU version neural network in Java. So maybe I can go through that and think about how to construct a CPU version as well. These two can be totally done in parallel. So the goal is to work on the neural network tasks in GPU version, which can be reused and assembled as any kind of neural network architecture. So our design principle is a neuron is a task. Maybe as a neuron gets a lot more, maybe this design will not be that good. But I think for a start, I think that is also a very good feature for the workflow system, or for the workflow, because every task we can manipulate different dependencies and how it executed. So I think it's an advantage we should take off and see how it works in the data view system. And we have several potential methods. The first one is I just found this one during the weekend. It's called IBM Java Runtime, and this is very good. Basically, it's a very good Java Runtime JVM. It basically includes some very useful libraries, and there's no non-Java code we need to write, and so that's very powerful. Because, for example, like here, we import the GPU ibm.gpu.math library, and we can directly use this math.sort array and to make the task to work in the GPU. So we don't need to care about much more than this. We don't need to set up kernel. We don't need to set up non-Java code except to this one. So I think this is a good option we can take. And second one is JCUDA. And by the way, the IBM runtime, Java runtime, also support the JCUDA. So that is also another benefit from this one. And the third one is Apple Pie. So I think this one is also very good option we can take. So basically, I think that's pretty much what I would be discussed today. So I hope you guys can enjoy this video. And until next time, happy coding.